So we finished off the session one video slightly further ahead than we got in the classes, but I'm not going to redo the bit from the session one video again. I'm just going to say that if you're coming to this from a place where you've missed the session two class, and you haven't seen the last bit, the bit I'll be talking about, then please head back to that video. So in the session one class, but not the session, we've made this date column. Let me go to table view. We made a date column that has year and Q and then the quarter in it. In the video, and I touched on this at the beginning of the session two class, we use a more complicated DAX function to actually format that quote unquote properly, so that we can have it as a date column. So if we look here, this is a date column where this is actually a text that we plot, and then in those plots put alphabetically so they come out as we expect them to. So I'm not going to touch on this date column. If you haven't got that, go back to the end of the last video and find out how to do that, because we'll be using that. The first thing we're going to do so the things we're going to do today is we're going to look at making a date table, which, as we have a date column, we don't need. We can still plot things by date and do time forecasting functions with it. But it's worth knowing how to do a date table if you have lots of dates on separate tables. You want to link them to one table together. So we're going to make the date table and show how to link our table to it. We'll also obviously looking at linking tables and then how to separate data and make a dimensional table, so you have facts in one table and dimensions in another. In this case, we won't be taking the data out of one table and putting it into a dimensional table, because we already have dimensions, but we're showing how to link those. In the homework, however, I believe I have set a task where you take data from one table and make your own dimensional table out of it. So let's get started by looking at how to make our date table. So I'm going to go to home and I'm going to go to new table. And this is quite simple. I want to know my first and last date for all of my data, and I'm going to make a table which has a column, which I'm going to call date, that has every day between those periods in it, so that I can then link that together and use that for plotting. And what this will allow me to do is it will allow me to, in my plots and visualizations and things, especially if I have more than just one table of data, take the date from the date table as one of my axes, and any other tables that link to that would then use that date rather than taking from one specific table. So I'm gonna call this column date. I'm gonna set it equal to, and I'm gonna use the calendar function. And if I go Control+, actually, I found out this makes it really nice and big. I'm going to use a calendar function. I'm going to go down to it. I'm going to pop in the first date, which I know because I've looked at my data. It's going to be date, and I want to set my start date and my end date, and that's going to be 2021 01. Oh, it's not dash, sorry, 2021, comma 01 01. And that's going to be my start date, and then comma, I want my end date. It's going to be date again, and it's going to be 2025 01 01. So 2025 01 01. And if I close that final parentheses now, this will make a calendar of all of the dates between 2021 and the beginning of 2025. So I hit enter, and after a while we can see that this should be all of these days normalized to midnight. So that's that there. There's a page that we talked about last week that we didn't look at too much, and this is the model view. And what the model view allows us to do. What the model view allows us to do, if I head into the model view, is steal up our different tables and see how they link to each other. And we can see here from our data LAs table from last week, we've got a date column, and we've got a date table here with this date column. I'm actually going to go to the right, and I'm going to right click this, I'm going to mark this as a date table. I'm going to click mark as date table. I'm going to select the column I want as my date column, and unsurprisingly, I'm going to choose the date column. There we go. If I already had a table I wanted to use as my date table, I could have a right click and select that as my date table. But here I've made one manually. Again, this date column here is made of dates, we can plot using that. But when we get more complicated models, it becomes good to have one isolated table that all the other tables link to show dates. So to link tables by a specific field, you click on the field you want and you drag it to the field you're linking it to. So I've clicked on date from data LAs, I'm dragging it to date. And you'll see a line's going to appear. And you'll see a star there and a 1 there. What this means is that there are many dates in this table which correspond to each having one date in this table. So there's lots of rows from this column that each match to one row from here. So there's lots of rows which have, say, the 1st of the 4th, 2022 in here, but there's only one 1st of the 4th, 2022 in here. We can also have one-to-ones if each table has one row here for one row here, and we can have the opposite. We can have one-to-many, which would be the case, I suppose, if these were the other way around. But what this allows us to do, well, actually, we don't need to have done this because this is properly formatted. It's a date, we have got other tables linking to it. But it allows us, if we make a new page, and I'm going to call this session 2, so rename page session 2. It allows us to do time functions. So if I go here and I make a bar chart, sorry, a line chart, and let's say I want to take measure value as my y-axis. I'm doing measure value because we used rate and percentage last week. And I want to do that against time. Well, last week I would have taken this date column here, which is the year plus the quarter, or this date column here and drag this in. But because this one here is linked to this date column here, I can use either. And again, if I had multiple tables linked together by date, I would have a preference for using this one. So I'm going to drag in this date column here to the y-axis. And this allows us to see something that doesn't quite make sense, because I've got count of date there, because I have flipped my axes around. So I actually want, there we go. I don't know why I did that. I've got my dates along the bottom, and I've got my counts of measure values. As we remember from last week, those filters are needed to make sense of that data. So if I pop these filters in here, I'm not going to sync them for now, although we can sync them so that each page looks at the same data, pieces of data, items of data. Let's go for just one local authority. Interesting. Let's go for, not interesting that these places seem to have one value in all of these. This doesn't seem to be as I would expect. Oh, because it's doing count rather than sum. So that leads us to another point. This is saying how many rows there are with a value in. What we actually need to do is we need to go to table view, and we need to go to data LAs, and let's have a look at measure value. So if I click measure value, we can see that that's text. And if I try and change that to a number, let's go to whole number, because values of children will be whole numbers. I change it, and I think we're not being able to convert it. Let's have a look down. There's probably going to be some suppressed values here where I've got numbers and letters. Actually, let me go through here. Well, I've got some dashes, which are suppressed values and zeros. If I go to the end, so it's just the dashes and the blanks that I don't like. So that's okay. I'm going to go to home and then transform data to a Power Query. When I'm in Power Query, so it's measure value that I care about. I'm going to right click on measure value. I'm going to replace errors. No, I'm not. I'm going to convert to a number first. So I'm going to replace values. Not right either. Sorry, I'm getting confused. I'm going to change type, and I can change these to whole number. Whole number. There we go. Oh, measure year. I'm clicking the wrong column as well. So I'm going to go to measure value this time. I'm going to go to change type, and I'm going to go to whole number. We're going to get some errors here. We see we've got that little salmon colored bar there. So I'm going to replace errors. In this case, I know, because I've looked at all the data, all of these errors should be null. So now I've replaced these measure values with nulls. I can close and apply. These changes are going to take a little while to apply. We'll wait for that to happen. Good, there we go. I'm going to go to report view. I can actually refresh this. I think this should work. Then I'm going to head to here. And where it says count of, I instead want to change that to sum. And there we go. We can see that this is the sum of all of the sin cases in Bolton. So let's change this to another local authority. So get rid of Bolton. I clearly have another local authority selected here. No, this is all. So if I click Barnsley, we'll get just the Barnsley one, same as last week. I can change from sin to children needed at the end of the period, something like that. And actually, let's go to this one, because it only really makes sense for us at this point to choose one local authority. So let's go to multi-select with control. So if I select BCP, I'm only going to have values from BCP. We're not going to worry about any of the formatting today. You can do that in your own time, and we talked about it last week. But what I will do is, if I click on this chart, you can see that we've got access to add further analysis to our visual. And because we have this properly formatted as a date, rather than using the year Q 1, 2, 3, 4 formatting like we did before, it allows us to forecast, which uses the previous values and whatever Microsoft has deemed fit as a forecasting method to predict future values. Now, looking here, it seems a bit silly to take, what is this, about 10, 20 data points to predict an equal amount. So let's open up the forecast bar and let's drop this down to 3 or 4. But really, you have to use your own knowledge of data and your local data and what you see as suitable for making predictions using this, the quality of your data, how longitudinal your data is, things like that, to decide how long you want to forecast. And really, I'm not saying that Microsoft Power BI's method of forecasting is good. I'm just saying that if you use a properly formatted date column, which does mean either this column which we made or the date column from this table, they will work. But you cannot do that with where is it? The date year plus quarter one, because it will take that as text. So that's how we can do some time series analysis, how we can make our date table and link tables. So let's look now at making a dimensional table. So I'm going to go to Excel Workbook again, and I'm going to open up the Power BI training folder, Power BI training notes. I'm going to pop data, which is the data about populations and other things that links to this RIA data set we're using. So I've opened it up, I'm clicking that I want this sheet, I'm having a look through and it seems right. So I'm going to load this in. There we go, it'll take a little while. 156 rows, that seems like the right number of rows for the number of LAs. And I'm going to head to table view. What I can now do is for both the data LAs table and sheet 1, which I'm going to rename as pop data. I could also call it something like dim LA to make it clear that it's dimensional data for the local authorities, but I'm going to call it pop data because we're using it for population data. I'm then going to head to home and go to transform data, and I'm going to choose the columns I want, so the ones that make sense to me. So choose columns at the top there. Region, yeah, don't really need LA code, don't really need report date. We're looking at data LAs here, actually. So no, don't need report date, don't need LA code, don't need region because we're getting that from our pop data. measure year, quarter, name value. We do need this other one. So that's okay. Let's select OK there. And then let's also look at pop data, which is the one we just imported, and we'll see which of those we need. So code, probably don't need LA code. Maybe if we're doing GIS or something later, we'll want that. Actually, you know what? Let's go to data LAs. Let's choose columns, and we'll keep LA code because that allows us to keep LAs with the same code, despite the fact they might change their names at some point. So I'm going to keep LA code, and I'm going to choose columns in pop data, and let's go local authority, keep that region, yeah. Type, yeah. Stat neighbor, we're actually not keeping, that's just a hangover from the old data. And we can keep these other things. So let's press OK there, and close and apply. Then, same as we did before with the date table, we're going to head to the model view. So let's wait for this to load. Head to model view. I'm going to take pop data over here. Remember, this is our old report page titles. I recommend everyone do this for today as well. I'm not going to go through it because I've already shown you once. And I'm going to go to LA code from this table, and I'm going to link this to LA code from this table. And we should once again have a many-to-one relationship. And what that means is when you're looking in a row which has an LA code from here, it will know to look in the LA code row from here to find a value when we're plotting things. So let's do something like, let's plot a field map. And we're going to take, maybe wrongly, because we could do all of this from the pop data table, but we'll do it this way just to show what's happening. We'll take the LA code from data LAs, and we'll pop that in as location. No, in this case, we need to take LA name. And then we'll take from this table, we'll take latest inspection result. That's date, that's outcome. So we'll take latest inspection outcome and pop that in as the legend. Interesting that it seems to think we've only got one local authority having been rated. That's because we've got BCP. Let's unselect that. And there we go. We've got all of our local authorities there. If we zoom out a little bit, we might see here, we've got one here, we've got them here. They pop up quite slowly. If your LA has ArcGIS, I recommend using that. It does its best using Bing and the names of each local authority to pop the local authorities here. But local authorities share the names with some places from the US. We can improve this by going, I think, to format your visual, map settings, controls, geocoding culture, and go to England GB. And that will aim to use the British places, but we can see here we've already got one place. Where's this? This is CE. For some reason, we've got a local authority in our data called CE, and it thinks that that is in South America. But if we look in, we can see that we've managed to really easily plot all of the local authorities and their offset results here. Again, if you wanted this to work properly, you would probably need to go through and clean all of your data to sort it out and make sure it looks as it should, so that this encoding culture works. Or use ArcGIS to plot the actual coordinates for all of the boundaries of your local authority. And if you have ArcGIS but don't have the information for those coordinates, you can find that by looking up, I believe, unitary authority boundaries on the ONS website. And then you'll probably need to, for the size of the file, scale those down using an online converter. So we've looked at making a date table, using that to do time series analysis, linking that to another table. We've looked at linking tables. We've looked at bringing in a dimensional table and linking that table as well, so we can see how we can link multiple tables together. Let's now, for the last little bit, look at how we can make some calculated column. So we're going to start a bit more DAX here, and we'll start with some more simple DAX and finish off by seeing how we can do all of the expressions we're doing together in one bigger expression, which starts to use some variables. I'm aware we used some variables last week, but it's nice to introduce them over and over again. So let's get out of pop data. Let's head into table view and go to data LAs. So we've got a measure value, and last week we already used the pre-made calculated percentage and rate columns. Obviously, there's only values where calculated percentage and rate are actually given, and there's a value there, so it won't be in everyone. But in this case, let's see if we had values, but we didn't have calculated percentage and rate, how we would calculate those ourselves. So the first thing we're going to have to do actually is we're going to need to go to pop data, and we need to go to the column we're going to use. We're going to assume that all of our measures are looking at only 0 to 25-year-olds. Obviously, if we were doing this properly, we'd make sure to do this only for the correct measures. But let's assume we're doing just for 0 to 25-year-olds now, so that we can do these calculations more easily. So let's click on this column. We'll see that it's text. And let's see what happens if we try and make this a whole number. I'll click on it, click yes, and we can't convert it. So there's probably some things in there that we don't want. Let's look. Well, we've got some dashes, which you can't convert to whole numbers, and it looks like that's the issue. So I'm going to press OK. Once again, this comes up all the time. I'm going to head to transform data. We should be masters of this now. I'm going to make sure I'm in pop data. I'm going to go to population of 0 to 25-year-olds. Let's go 0 to 17. Actually, that makes more sense. So population 0 to 17. I'm going to go to change type. I'm going to go to whole number. This will then give me a bunch of errors. We can see with our salmon color there. I'm going to right click. I'm going to replace errors, and all of those errors with dashes, so it's going to be fine to replace those with nulls. I'm going to press OK. There we go. Close and apply. I know I've said this a bunch of times, but for simplicity, think about the techniques I'm using and the DAX I'm using and stuff like that, rather than the actual way I'm working with the data we have. I'm trying to show as many things as I can with data that everyone has access to, rather than showing you what I would actually do with this data. So take away from it the process I've done, and then with your own data, apply the correct ones in the correct places. So I'm going to head to data LAs, and first of all, what I want to do is I want to show how I can bring in, using DAX, an extra column which takes the population value from pop data and pops it in here to make a new calculated column. So I'm going to go to new column up here, and I'm going to call this pop. And you'll see that this is a roundabout way of doing the thing I really want to do, because we can do this in one column later. But let's look at it bit by bit first of all. So I'm going to call this LA pop for LA population. And I'm going to use a lookup value, which is very much like an HLOOKUP or a VLOOKUP or an index match, that kind of thing. And it looks at the value in this table, finds that value in another table, and returns a different column from another table. So I'm going to do lookup value, and I want to look in the pop data table. Let's go pop data. And I want to return 0 to 17-year-olds. So the first thing, if I look at this tooltip here, is going to be the result column name. So I'm going to go pop data, I'm going to 0 to 25-year-olds. Then I'm going to look for the column I'm searching for in that table. So I'm actually looking for LA code. And I'm going to look for data LA's LA code. So I'm saying the column I want, the column from that table, I'm going to look to reference the table I'm in, and the column from the table I'm in. I'm going to close that up. And if I hit enter, this should, assuming I've not made any typos, fill with the correct values. You'll see that some local authorities, so like Northamptonshire, don't have values in. And I'm imagining if I go to top data, let's have a look for Northamptonshire. We will see that Northamptonshire doesn't have a value for this. So Poole doesn't have a value. Where's Northamptonshire? Local authority. Let's deselect those, go down to Northamptonshire. There we go. Okay. You'll see that Northamptonshire didn't have a value. So that's fine. That whatever year the report was done, it didn't give a value. But that is how we can bring from one table the data in using a lookup value. What we can now do is quite simple. We can go new column, and let's make using DAX our calculated rate. So let's call this, just for simplicity, DAX rate. And it's going to be equal to, well, we simply want to divide for rate per 10,000, measure value by population in each row and times that by 10,000. So I'm going to put brackets there. I'm going to do divide. I could also just do a slash for divide, and I'm going to divide, remember apostrophes to give the table, and then square brackets for the column. So apostrophe measure value, and then comma, and I'm going to do again data LAs, and I want LA pop, and I'm going to just do a star to do times. This time I'm going to do 10, 1, 2, 3. There we go. I'm going to hit enter. And if we scroll down to somewhere which has values for both, let's find somewhere with a measure value, we'll see that this is the same 5.64, 5.69. So there will be, it seems, some rounding errors, or if one has used a different population to do that, but they are close enough. This was calculated originally in Excel, potentially using different population data. I got this population data from a different document to the RIA, so that might be why that is. But it's similar enough and shows the process. As I said, we're not looking at how I would use this data, we're looking at the techniques I'm using. So once we've done rate, let's expand our DAX a tiny bit to do our percentage column. So let's go to table tools now, and let's do new column again. And this time we're going to do percentage. So let's call this DAX %. And I'm going to make a new line, and I'm going to make some variables. So I'm going to do capital VAR, and then I want my variable. This is going to be measure value, call it MV, and it's going to be equal to the value that's in the data LA's measure value column. And I'm going to make another variable, so VAR, and I'm going to call this pop. And this is going to be data LA's LA pop. So we can see that if we want to do some DAX and we want some variables, rather than in the previous column where we put this whole thing in our expression, this time we're making life a tiny bit easier for us in terms of readability. We're saying, well, I want MV to be this, whatever it is in a column, and a row, this to be whatever it is in a row, and then I can write a return which tells the expression I actually want, which is going to be, so shift enter again to make a new line. I'm actually going to tab both of these in. Oh, only one tab. I'm going to go down and I'm going to return. I want, quite simply, I'm going to brackets around these, MV / divide, MV divided by pop times 100 to get the percentage, and hit enter, and then that's the DAX expression for our percentage. So there we go. Let's go down until we can find a place that's given a calculated percentage. There we go, 0.8 there, and we go along. And interesting that that's different there. Interesting that that's different there. No, these are both as we expect, so 0.12, because it should be a 100th of that. So interesting that the percentage is so vastly different. Let me think about this. I am doing this on the fly, by the way. which is why I might have things that I don't expect coming out. Is it because these are of a subset? So 0.46, 0.46, 0.07. Okay, that's very interesting that they are such different numbers. Is it because these are percentages of percentages? So this is the number I would expect to get. So I'm wondering what this calculated percentage is calculated from. I think the point to take from this is that this is still the percent of the total population. I'm just not entirely sure what this calculated percentage is calculated percentage of. I hope I've not misled anyone there. The DAX still stands. Maybe my understanding of the RIA data, which I actually don't work with anyway, is the issue here. But let's use the things you found from these three previous columns to do all of that. Let's do the rate, because that's the one that actually lines up in a way that makes sense. So I'm going to make a new column, and I'm going to call this DAX 1 expression. Obviously not very good column names, but they work for what we want. So I want a variable. I'm going to call it var. And now we can see more of the reason why we might want to use a variable, where for the last column, it was quite simple. And the variable is going to be the whole lookup. No, so I'm going to call it pop again. It's going to be the whole shift, enter, there we go, lookup value expression we gave before. So pop data, and we want to give 0 to 17. I wonder if it's because I use 0 to 17 rather than 0 to 25. So let's pop in 0 to 25 rather than 0 to 17, which I gave before, and see if that comes out differently. So pop data 0 to 25. I'm going to look in code in the other table, and in this one, I'm going to use data LAs. I'm going to use LA code as well. So that's variable 1. Variable 2 is going to be the MV, so measure value. So I'm going to go var MV equals, and shift enter, and then tab, and it's just going to be the data LA's measure value. There we go. And then I'm going to return without the capitals. I'm going to return, I'm going to use divide again, just because it's nice to use different things. MV and pop. I'm dividing MV by pop, and I'm timesing that. Let's times that by 100. And see if this number looks more like the one we were expecting. So I've done something wrong here. Probably population 0 to 25, I haven't converted yet to a number. So let's go into 0 to 25. Let's go to column tools. We'll see it's text. So I'm going to right click. No, I'm not. I'm going to go to home, transform data, 0 to 25 in the pop data. Let's go across to 0 to 25. Right click, change type, whole number, errors, replace errors with nulls. Okay, close and apply. Head back to this DAX 1 expression I've made. Then hit enter again. And we'll see that it's not got errors anymore. So let's see these values. So let's go to where some calculated percentages. 0.99, 0.24. Interesting that once again, that's a different value. It is a tenth of a calculated rate. So these, given the RIA data, 0.73, 0.74, 0.19, clearly they're being divided by different numbers, because these DAX rate and DAX percent always seem to match up with the calculated rate, but they don't seem to match up with the calculated percentage. That is interesting. Let's go to tax percent again. Measure value over population times 100. That's how we calculate percent. So I'm not entirely sure what's going on. Presumably my misunderstanding of the RIA data. In any case, let's, before we finish, make one last column. And we're going to learn about a better way to do if columns. So let me quickly bring up my notes. So we can do in DAX an if, where we write something like, if it's this value, give this, if it's this value, give this, if it's this value, give this. But instead of that, we can use something called a switch true, which gives us a much shorter syntax for writing them. So let's have a look. Let's invent a measure. It doesn't exist, and we call it measure concern. We're going to set measure concern equal to. On the next line, we're going to hop in switch true. So let's go tab and let's go switch. And in our switch true statement, the first bit of it is going to be just true. And basically how the switch true works is that when something is true, it goes through that row and returns the value given to it in the switch statement if it's true. So let's make a new line and we'll talk about that a bit more clearly. So let's say we want to say give a low, medium, high, and NA for every measure based on the rate per 10,000. Obviously doesn't work. The rate per 10,000 of some things can be the rate per 10,000 of another thing. And it might be really, really concerning to have 100 UASC, but not really concerning to have 100 early help things, that kind of thing. So it doesn't quite work. But again, we're looking at the switch true expression rather than what we're actually doing with the data. We're just working with some data we understand. So let's go data LAs. And let's look at the calculated rate here. So we know that we've got a number that makes sense. And we're going to say if that is greater than or equal to 500, we want to return I. In this imaginary world, a rate for 10,000 greater than 500 is I. Then let's shift enter. And the way this works is that we could have done this with if. So if data LA's calculated rate is greater than 500, return high. Instead, we're doing it with a switch. And where this is true, it will give this. Let's go data LA's calculated rate again. And let's say if it's greater than or equal to 100, comma, it's medium. That's gonna be an error because I hit enter without meaning to. I meant to be shift enter. What we then do is the last statement is kind of our else statement. So if this is the case, it will do this. If this is the case, it will do this. Otherwise, it will do something else. We want to say actually that if data LA's calculated rate is equal to 0, we want to say NA. There we go. If calculated rate is equal to 0, we want to say NA. Otherwise, which means if it's between 0 and 100, because that's what's left, we would like to say low. So the measure concern will give us high if it's over 500, medium if it's over 100, low if it's between 0 and 100, and if it's 0 or null, it will return NA. Let's hit enter. So you've got NA all the way here, and then let's go down until we've got, there we go. So high, where the rate we've calculated is over 500, medium, where it's between 500 and 100, and so on and so forth. And then we could feasibly go back to our plots here, click on this where we've got inspection outcome, and we can pop measure concern instead on our legend. And then we've chosen all local authorities, and we can see for each measure at a time period, if we were to pop time period in. So we could choose a slicer of, let's bring in year plus quarter here. So let's choose the most recent one, 2022 Q4. We could go in and see the measure concern for each measure in all local authorities, assuming that that was a real thing. So let's quickly go through what we've done. We've looked at making a date table and linking that. We've brought in a dimensional table and linked that. We've done some time series analysis, which at the moment you can't see because we're only looking at 1 quarter. We've also looked very, very briefly at making a core replay. We then looked at some calculated columns, how to do that in the most simple way, and then gradually increase the complexity. I will be having a look at how the calculated percent are doing, are calculated. I will put something about that in the description of this video. And hopefully I will get to that before I actually give this class tomorrow so I can make it make sense. Thank you very much, everyone. I'm going to stop recording now and hopefully see everyone in the sessions. Goodbye.